Hello, I'm Dr. Levon Hairapetyan, a business professor at Houston Baptist University. In this video, I will demonstrate how we can do partitioning with overfitting using analytic solver. So what's the essence of this over partitioning? Remember this, in this chapter, we will work with supervised data mining methods. And all supervised data mining methods, the first step is to partition the data set into training, validation, and test sets. So what's the reason of that? Here's the idea. When we create, in supervised learning, so model is create is learning based on the real or available data, and that model is used to predict or classify new data. But by doing so, models can may be overfitted. And when we say model overfitting, it occurs when we build a model which on the special data set, and it works fine on that data set. However, it doesn't work well outside of that data set. And so in order to overcome this overfitting effect, the data set is divided into three subsets called training, validation, and test set. So training set consists of data used to build the model. So model is built or model is learning on training set. Then validation set is used to select between few models. So if we trained few models on the same training set, then if we want to figure out which model is the best, we cannot use the same training set because models were learning on that training set. So we need a new data set. So that's what validation set comes in. So it is used to compare compare models created based on the training set. And finally, when the best model is selected, then the test set used, the third set is used to calculate or to estimate effectiveness of that model. So one more, let me summarize this short. All supervised learning methods start with partitioning data into three sets called training, validation, and test. So training set, this is the set which is used to train the model or models. Validation set, this is the set which is used to select the best model. And test set this is the set which is used to estimate the effectiveness or efficiency of the model. So how many elements we should include in these partitions? There is no definite rule for the size of those three partitions. In general, a training set in many cases are the largest. And the rule of thumb is that the training set should be at least 10 times as much large as the number of observations. Now, when we are interested in classifying a very rare event, for example, fraudulent credit card transaction, then it's recommended that the training set oversample the number of observations related to that event. What does it mean? So it means that I put an example here. If only 1 out of 10,000 credit card transactions is fraudulent, then if we randomly select one less, like 9,999 transactions, then theoretically none of them could be fraudulent. So if none of them is fraudulent, then how the model can learn about the fraudulent transactions and then use that information for future classifications. That's why we do oversampling. So oversampling means taking more observations which contain that fraudulent, rare event. The suggestion is just approximately half in the training set should be related to observations which contain that rare event. For example, if we have our sample training set consists of 800 observations or credit card transactions, then approximately 400 of them should be fraudulent transactions. I want to emphasize that this rule, which means oversampling, is used only for training set. It is not used for validation and test set. For validation and test set, we just use some proportions. Now I will show you how we can do partitioning using analytics solver. And I will demonstrate that on the file Optival large row, which I'm about to go there and demonstrate it. And this file contains more than 43,000, yes, it's T, 43,000 observations or 43,000 credit card or transactions, or actually it was loan applications. And only 1.81% of those customers, of those 43,000 plus customers, have defaulted on their loan, which means loan default is a rare event. Therefore, if we want to do partitioning, and we need to do partitioning if we want to use this data set for future analysis, then we need to do partitioning with oversampling, because loan default is a rare event. So everything which I'm about to do in Excel, I wrote here step by step on these 2 slides. And by the way, this is what you are watching right now. So make sure that when you practice, go ahead and redo this from scratch and compare the result which you will get with the provided solution. Now let me switch to Excel, and so this is the file with 43,000 plus. Let me show you that I will jump to the last record. See, 43,193. This is how many customers I have, observations I have, and for each customer I have the following information. Customer ID is, in fact, it's not input data, it's just a label. But the actual variables are loan default, which will be 1 or 0, 1 meaning loan default, 0 meaning no default, average balance, age, whether person entrepreneur or not, unemployed or not, married or not, and so on. So in this case, the number of the loan default, this is the variable, which is a very rare event. I encourage you to calculate percentage of default loans in this big file. And I did that in my solution using very simple pivot table, and I will encourage you to do it yourself. If you cannot, then check the solution. It's extremely simple. Now let's do partitioning with oversampling. Click anywhere inside the dataset. Go to the data mining, select partition. Oh, let me cancel this. It's already partition, this one, partition, and that was time series partition. We need the partition related to data mining. Partition, and we select partition with oversampling. As always, the first thing is we have to carefully check and make sure that the data range which is Excel found is correct data range. In our case, it is correct. This box is checked because the first row contains labels, headers. And then these are my variables. And since we will do partitioning for the future data analysis, we will include all variables into partitioning. So I'm selecting all of them and moving into this area. I didn't include customer ID because it's not a variable. Now, remember we are trying to do partitioning with oversampling. And the reason for oversampling is because loan default is a very rare event. And we have to tell analytics solver that this is the variable which will be used for oversampling. The way we will tell it, we'll select this and then come down and click this arrow. And you can see that loan default is listed. It's listed in here too, but it's listed also as output variable, which will be used for for partitioning with oversampling. Here I will check this box to specify randomizations. Number of classes, we need 2 classes. We have 2 classes actually, class 1 and class 0. Class 1 will be lone default, class 0 will be no default. When we have a variable with 2 categorical values, a categorical variable with 2 values, like in this case lone default has 2 values, then it is common to use 2 generic names for those values, and those names are success or failure. So success does not mean it's a good outcome, failure, bad outcome. These are just 2 generic names to name 2 different possible outcomes. So in this case, we selected 1 as success, which means success in this case, success will be lone default. Now, dataset, Excel already calculated that the rate percentage is 1.81. So 1.81% of all observations are with lone default. Then success percentage, we will leave 50 here default. Let me add 40 here and click OK. And wait a little bit. And what analytics software did, it created a new data set, new tab. And on this tab, we have the same data set, the same observations, but now they are grouped into 3 subsets: training, validation, and testing. And these are the number of elements in each subset. Basically, we didn't do any data mining yet, but we did the first step, because every data mining algorithm which works with any supervised data mining method starts with partitioning the data set. And depending which type of the data set, we may have either partitioning with oversampling, that's what we did right now, and there is also another partitioning method which I'm about to demonstrate in my next video, when there is no rare event. And in that case, we will just use standard partitioning. So this concludes my today's lecture. Have a nice day. Bye-bye.